Tackling something. Measurement and sampling techniques is what we're talking about today. But before we do that, I need to explain something to you. One of the reasons I want you to write a research proposal is because I think that's the best way to learn how to actually do research, to understand research. Because if you go through the entire process, through all the little minuscule things that you have to think about, then you have to think about them. And that teaches you how research works. It's not easy. Research isn't easy. It's just because you got a problem doesn't mean that you're going to be able to come up with a way to measure it. A good example is missing and murdered women, indigenous women. Um, Professor Barber and I talked about this when he was thinking about what he was going to write his dissertation on. We talked about this for months, trying to hash it out. And then once he landed on this topic, the two of us, well, he did almost all the work. All I served as was a sounding board, and we talked about this over and over again. Some of the things, of course, he's done. He did some private investigation looking for missing women, um, and there's it's a mess. It's quite a mess, and part of the problem is, let me explain to you what he ran into. One of the things he ran into was when you got somebody that's missing. Um, you don't really know what happened to them. The family is very adamant about finding them. But if there is someone that is was involved in that situation, that whole family is trying to not deal with the situation. So you got one family that's pulling you in one direction, you got another family pulling you in the opposite direction. Somebody's trying to find the individual, the other one's is saying, "No, she's just gone. Don't worry about it. Let's not even worry about it. Let's not even think about it." And that's what he ran into when he was doing his investigations, his private investigations. So sometimes, how are we going to measure all this stuff? And of course, that's one of the things that they were hoping for. They were hoping that they would, be able to put this on the internet, and then people would find them, and if they were being trafficked, people would be on the lookout for them, and of course that's happening. But at the same time, there's a lot of different things that can cause individuals to disappear, including runaways. And of course, that's part of it as well. So, not every problem has a research proposal. Not every problem can be researched. So, let's go through. So, today we're talking about research. That's not right. Measurement error, intervening variables, and sampling techniques. That's what you're going to be doing in the fifth week. You're going to be looking for those two things. So let's go through the. I've got a new one. I've got a new piece of research that we're going to talk about. That is a possibility. Okay, so let's talk about my original research from my dissertation. It had to do with resilience. Oops, I'm sorry. So the problem was that I saw that there was a lot of resilience that people weren't recognizing on some of the Indian reservations, especially up in Montana, and they were focusing on the negative, but they weren't focusing on any of the positives. So that was the problem that I saw. So I wanted to show that there was resilience on the Indian reservations up in Montana. And so the unit of analysis was resilience. The unit of observation turned out to be a test that I came up with that measured resilience. The hypothesis was that the population of the reservation that I was dealing with, Fort Belknap Reservation, the people showed resilience. And the null hypothesis was that they didn't show resilience. The dependent variable, of course, was the resilience score from the test. And the independent variable, there were 5 of them. One was age, gender, education, level of trauma, and level of culture. The amount they identified with their culture. Those were the independent variables. Ethics involved, it got real complicated. Because there was no IRB on the reservation. The college put together an IRB, but there were politics got involved. Tried to get the tribal council to approve it. They didn't approve it. I told them that this was a way of combating suicide, and they voted it down, missed it by 1. So what I did was I didn't survey anybody on the reservation. I just surveyed indigenous people off the reservation in Blaine and Phillips County. The reservation is actually in both counties. It has parts in Blaine County and parts in Phillips County. There's a reason why they did that in Montana. All the reservations straddle at least 2 counties, and the reason they did that is so that the indigenous population couldn't become a political power in either county, as ugly as that sounds. So the data collection that we were dealing with, I had 3 measurements and a demographic survey. The three surveys encompassed resilience, of course. One encompassed ethnic or identity, cultural identity, and the third one dealt with level of trauma. And then there was, like I said, there was a demographic survey that gave me information about their age, their gender, and their level of education. So the population I used was the indigenous population off the reservation. The intervening variables was that they didn't identify as very strongly as a indigenous person was one of the variables. Another was that potentially they would not give me a very accurate answer as far as trauma was concerned. But it was a good survey, and it was able to winkle out a lot of information, but it wasn't invasive. The sampling technique I used was a census sample because I knew the names of the individuals who were from the reservation, and they were very distinct from most of the other names that were not indigenous. And what I'm talking about is that most of the white people that settled in the area were from Eastern Europe, so they had Eastern European names. And the people that were from the reservation had very distinct names, like Talks Different and Stiff Arm. I'm trying to think of other names, but they're not coming to me right now. Anyway, yeah, Johnson. Johnson was actually a very common name on the reservation, and it wasn't a common name off the reservation, strangely enough. And you may ask yourself why? Because they were Eastern European. They didn't have. Johnson is a English name. Okay. What else? Okay, so that was my sampling technique, and that's it for that one. Let's talk about loneliness now. So loneliness as the problem with loneliness since COVID-19, more people are reporting a feeling of loneliness. That's nationwide. The unit of analysis will be loneliness. The unit of observation, I found a survey, the UCLA loneliness scale, and I can show it to you right here. Come on, there we go. Okay, that's a loneliness scale. It's actually 20 questions. And there's the 20th question. People are around me, but not with me. Anyway, loneliness scale. The hypothesis, since the 2020-2022 pandemic, people are feeling more lonely. Null hypothesis, people aren't feeling any more lonely than they ever have. That would be the null hypothesis. The dependent variable is loneliness. The independent variable, and that has to do with all the questions, all the 20 questions are my independent variables. Well, actually, are they going out less? Are they communicating less? Are they spending more time alone? Are their plans for the future more isolated? And that we can get that information from the questions. The ethics, I don't see any problems with the ethics. Data collection, create 2 surveys, one about COVID, the other present. Asking questions like, in 2019, I went out with friends how many times a week? And I texted friends how many times a day? I called friends how many times a day? And then the other one would be in the present. Is that right? Yeah, the other one would be in the present. So we would compare the two, 2019 survey and then the present survey. And then we would send them the loneliness scale. To see how they would do on the loneliness scale. The population, I would find volunteers to take my surveys. So the population would be anybody that's willing to take the survey. We could do it on the reservation. We could do it in the general population. We could do it in Iowa. We could do it in Arizona. Do it in New Mexico. We could do it all over the United States. Intervening variables, depression will test as loneliness, and I'm not exact that there are different definitions for loneliness and for depression. Loneliness may be situational or momentary, and so it will look like they are lonely, and those are the intervening variables. Sampling technique would be random. Okay, I've got a new one. Are you ready? I've got a new piece of research that I want to do. And this has to do with general knowledge of the reservation, general knowledge about the Navajo Nation. I'm not sure you guys are very realistic about how much knowledge people have. I keep being told that people ask me if if we still live in teepees. Well, let's just find out how much knowledge they actually have. The unit of analysis. So the problem is that there isn't enough general knowledge about the Navajo Nation in the United States. And the unit of analysis will be the questions about the Navajo Nation. The unit of observation, general knowledge questions about the Navajo Nation. Hypothesis, the general public will know at least 5 out of 10 general knowledge questions about the Navajo Nation. The null hypothesis is that the general population will know fewer than 5 general knowledge questions about the Navajo Nation. The dependent variable is the total number of questions answered correctly. There's only 10 questions. I'll show you the questions in just a second. And the independent variable, each question will be an independent variable. Okay, and I'll show you the general knowledge questions right now. There you go. So the first one is, the following heavy metal has been mined and what has caused problems on the Navajo Nation. And of course, if you look at these, the answer is always A. But of course, if you live in Upper New York State, do you know that uranium was mined on the Navajo Nation? The Navajo Nation recently closed the largest coal-burning energy plant in the United States. That is something that probably only people in Arizona or people on the Navajo Nation are aware of. The Navajo Nation is located in which of the following 3 states? Okay, so some people may not have a clue where you guys live. And of course, it's Arizona, New Mexico, and Utah. But they may think that you're, down by, I don't know, the point of Nevada, or in the middle of the country, or over in Texas somewhere. Maybe they don't know where West is. They just think of West as not New York. The fourth question, environmentally, the Navajo Nation is mostly high and low deserts. They may think that you live on the Missouri or the Red River, or maybe you live up in the high peaks of the Rockies, which are actually, and I looked this up, they're actually all in Colorado. The other indigenous tribe, the Navajo, have recently had grazing and ownership conflicts with are the Hopi, of course. COVID-19 caused many deaths on the Navajo Nation. This was public knowledge. It was being reported on frequently, relatively frequently, but people don't notice anything that isn't on there, doesn't deal with them. The seat of government on the Navajo Nation is in Window Rock, of course. Navajo share a language with the Apache and tribes in Canada. And if I actually was going to do this, I would ask you to edit this for me. Some of this referring to the Apache tribe as Apaches may not be acceptable. I know they would rather be referred to as the San Carlos Band and the what else? The White Mountain Band. So using the word Apache may not be proper, may not be acceptable, and of course that would be for you to decide. And any of these other questions, you go, you can't say that. What are you talking about? Well, you talk like a white guy. Number 9, Navajo people call themselves the Dene, which means children of the holy people. That's what I understand. That's what I've been told by several people. Some other people just say the people or the holy people. I've heard that as Wilson told me that, so I assume Wilson knows what he's talking about. Masters of the Universe. That's an old television show. Okay. It is estimated that the number of people speaking Dene Bazad, the Navajo language, approaches, and the answer is 175,000, which is pretty good. That's better than any other Indian tribe, any other indigenous group in the United States. So, okay, if you have a comment about this, I'm just a flatlander. I'm just a silly flatlander living in the middle of a cornfield. So if you would like me to change any of these questions, go ahead and give me the word, and I'll be glad to change them. I like the questions, though. I mean, I like the possibly the wording. I'm not exactly sure that Sioux would fit. Those individuals refer to themselves by their language group. Lakota, Nakota, or Dakota. I don't know. Anyway. Okay, so the data collection is just these 10 questions, and I was thinking, hey, I could just put this on the social psychology website. I don't know how you get approval to get it done. So with that, we would do that, and we would probably get people from all around the world. Population, yeah, like I said, we'd put it on the social psychology website. And anybody around the world could take the test. And that might be fascinating to see how they did. Intervening variable, individual uses the internet to answer the questions, and of course that would just really mess things up. Sampling technique would be fairly random, and that is another way to do it. So This is the fifth week. Every week I'll go over these three types of these three pieces of research. This is what I need you to do. I want you to do a research proposal, not because I'm trying to torture you. Oh, I can't come up with anything. I'll be glad to work with you on this. I just want you to understand how it works and how difficult it is. How difficult it is to come up with all of this stuff. Those of us who do not plan to do research, I don't want to do research past my dissertation. That was enough for me. You know, Professor Barber was in the same boat. He had never done research before either, and so this was coming up with a research proposal. You know, writing 100 pages on his topic, really tough. The good news is that it's an academic review, so potentially he will be Dr. Barber by the beginning of the semester, I hope. Fingers crossed. Nice guy, deserves it. Okay, so there's my general knowledge test for the Navajo Nation. Yeah, oh yeah, I changed a word. Okay, also I'll keep that around. Could be fun. Um, when you live someplace, you think, well, everybody knows the same stuff that we know. You know, I'm from Indiana. Everybody understands that in Indiana, people from Indiana are called the Hoosiers. And then you go to North Carolina and they have no idea what you're talking about. So it's kind of the same way. You're not aware of how much information people have about you or about where you live. You know, people just don't know. Anyway, so let's go ahead and get started on the today's lecture. We're going to talk about Chapter 7, Measurement, and then Chapter 8, which is Sampling Techniques, I think. Yeah, Sampling Techniques. Okay. So please, if I said I don't know that we can do research on this, I will be glad to work with you because that's a major part of your grade for research methods is coming up with a research proposal and answering all these questions that I'm answering for my three pieces of research or three types of research. You need to answer all these questions. Of course, I don't expect you to do the research, but you know, it's that's that's how we're going to finish the class. That's what we're going to do. Okay, let's go ahead and get started. I'm going to run out of drink and I'll probably be talking like this. Oh, wait a minute, I got some more. Measurement is defined as a procedure whereby a researcher assigns numerals or other symbols to the empirical properties of variables according to a prescribed set of rules. That sounds awfully complicated, but it isn't really that complicated. My survey, you know, did you get it right or did you get it wrong? You know, you had 4 chances to get it wrong. No, you had 3 chances to get it wrong and 1 chance to get it right. 3 basic concepts to define measurement. Numerals are symbols that are given quantitative meaning and then become numbers that make possible the use of mathematical and statistical techniques for purposes of description, explanation, and prediction. And this is the way you do it. And this is one of the reasons why when my son, who is a mathematician, an applied mathematician, why my son had a difficult time teaching statistics to psychologists. And the reason is because his numbers are pure. His numbers really mean things. And our numbers, we kind of make them up. I had a student who actually just finished his PhD a couple years ago. When he did research for me, when he wrote his thesis at Ashford, he took the statistics to the head of the statistics department because he was a math major, a math minor, and so he took it to the head of the statistics department to help him figure out the statistics on his research. And the guy was just flummoxed. He had no idea what was going on. Because in mathematics, numbers are pure. But in psychology, we assign numbers to certain things. And he just couldn't understand that because that wasn't pure. Is this always the way it is? And the answer was, well, yeah, but we have to make it up. We have to make it up. And that's one of the reasons why psychology is one of the soft sciences rather than the hard sciences. In physics, gravity is always the same thing. The distance from the Earth to the moon actually changes all the time, but it's still a number. Still a pure number. But in psychology, when you're talking about Beck's depression inventory, and you're assigning 4 points for very depressed and 0 points for not depressed at all, where does what's a two? What does two mean? And medicine does the same thing. Medicine will ask you, well, how severe is your pain? Here, point to the smiley face, and if you point to the seventh one, they give you 7 points. Wait a minute, okay, so is my pain just as severe as somebody else's pain because I pointed to the same face? Anyway, so numerals are symbols that are given quantitative meaning, but it's not pure meaning. It's not always the same thing. Assignment refers to the mapping of symbols onto objects or events. Rules they explicate the way in which numerals or numbers are to be assigned to objects or events. And you understand what I'm talking about. We're just assigning these numbers, and potentially they have intensity meaning, but it's not absolute. Like with mathematics. Rules are the most significant component of the measurement process because they determine the quality of the measures taken. The function of rules is to tie the measurement process to reality. And the reason I have this mask up here is because that's virtual reality. As weird as that is. Oh my goodness. He's living in a virtual reality world. Or he's seeing a virtual reality world. Isomorphism is a mathematical term that means similarity or identity of structure. In determining whether a measurement procedure is isomorphic, the central question concerns not just the degree of congruence between the particular numerical system that is being used and empirical reality, but also the concept being measured. Social scientists measure indicators of concepts, and often multiple indicators must be developed to represent abstract concepts. And that's the problem. All of these concepts are abstract. Depression, we think, depression, everybody understands what depression is. No, it's an abstract concept. Schizophrenia, ADHD, all of these things are abstract. They have to be defined. They're not absolute. If we see PTSD, for the longest time we didn't identify PTSD as a problem. Even though we saw it in World War I, we saw it in World War II, and we especially saw it after Vietnam. And it actually didn't become a diagnosis, a mental illness diagnosis, until the 1980s, despite the fact that all those people who fought in the Vietnam War in the 1960s and the 1970s, about a third of them were coming back with PTSD, but we hadn't even defined it yet. All of these things are abstract concepts. Addiction, internet addiction, does that exist? The fact that you're constantly on your telephone checking your email to make sure somebody didn't text you or whatever. Communication. The communication is absolute and it's constant now. Is that an addiction? Is that an obsession? Well, those are both abstract concepts that we have to define. Indicators are terms used to refer to a concept. Indicators should be grounded in both theory and empirical observation. Indicators are used to measure a concept. They should derive from theories and practices of that concept. Economic giant or social pygmy. Life expectancy, birth years in 2011, 65 in India, 69 in Bangladesh, 75 in Vietnam. Infant mortality per 1,000 births in 2011, 47 in India, 37 in Bangladesh, and 39 in Nepal. Access to improved sanitation by percent in 2010. India 34%, improved sanitation. Pakistan 48, and Bangladesh 56%. Mean year of schooling at the age of 25 or above the age of 25 in 2011. 4.4 years of schooling for people above the age of 25 in India. 4.9 in Pakistan, 4.8 in Bangladesh. Female literacy rate percent age between 15 and 24 in 2010, 74% in India, 96% in Myanmar, and 97% in Bangladesh. Male literacy rate percent age 15 to 24 in 2010, 88 in India, 96 in Myanmar, and 97 in Vietnam. The concept of democracy can be represented by several different indicators. The fairness of elections, the degree of competition between political parties, the freedom of the press, the freedom to organize, and the rights of minorities. And of course, this is being argued right now by the two political parties. The election in 2020 was debated, not because there were any irregularities, but because one side didn't like what happened. So right now, we're arguing about all of these things. The side that lost is trying to figure out, well, how can we win next time? We don't seem to have as many people who are members of our party as the other party. Really kind of fascinating if you watch the news from day to day, watching this concept of democracy being debated back and forth in Congress by all the political powers. 4 levels of measurement: a nominal level, ordinal level, interval level, and ratio level. And these were developed by Stevens in 1946. And I think, yep, here we go. Okay. Nominal level is the simplest level of measurement. It functions solely for the purposes of classification. Symbols are used to classify objects or events into categories. Nominal level is used when the properties of a variable can be classified into a set of categories that are both exhaustive and mutually exclusive, such as gender, male or female, and now, of course, you could add other things. What is your hair color? They're just assigning numbers to brown, black, blonde, gray, other. Okay, what other color could you have? Red, I guess. They missed red. Ordinal level measurement allows for classification and also degrees within the classification. Examples: productivity, socioeconomic status, democracy, intelligence, education, and motivation. Whenever a phenomenon or process has a range, such as greater than or less than, highest to lowest, etc., you have an ordinal measurement. How do you feel today? Very happy, unhappy, okay, happy, very happy. Oh, very unhappy. I'm sorry. Okay. How satisfied are you with our service? Very unsatisfied, somewhat unsatisfied, neutral, somewhat satisfied. 5, very satisfied. Interval levels of measurement rank a set of observations in terms of the relation and also the exact and constant distance between each of the observations. In addition to saying that one object is greater than another, you can now specify by exactly how many units the former is greater than the latter. Interval data need a precise unit of measurement. Examples, your income, your intelligence level, IQ test, scholastic aptitude, that's your SAT score, your voter turnouts, it's an absolute number, and crime rates are also absolute numbers. And there you go. Prevalence of anemia in children under 11 years of age in Mexico in 1999. They're talking about anemia, which means they're probably not getting enough protein if they're anemic. Ratio level data are variables that have absolute and fixed natural 0 points that can be measured. A ratio level of measurement is achieved only when it is possible to attain all four of these relations: equivalence, greater than, known distance of any two intervals, and a true 0 point. In the social sciences, this might translate into length of time migrant workers typically stay at a single job site, number of community affiliations, number of occupations held by a certain age, your weight, the time, the length of something. Due to the precision of numerical measures used on the ratio level, higher powerful statistical manipulations can be performed on these values. Sample pie charts and bar charts of nominal data. Democrats and Republicans. Democratic Party has 44%. Republican Party has 33%. Independents and others right there, 23%. So as you can see, there are a lot more Democrats than there are Republicans. And that can be a problem for the Republicans. Variables that can be measured at the ratio level can also be measured at the interval, ordinal, and nominal levels. As a rule, properties can be measured at a higher level, can also be measured at lower levels, but not vice versa. Differences in scores that are due to anything other than real differences in the aspects of the property being measured are termed measurement errors. Common sources of measurement errors: the scores obtained may not be related to the attribute the researcher intended to measure, but to another associated attribute. Temporary differences in conditions such as health or mood, which may affect a person's responses or behavior. One time, we took IQ tests every year, and there was a reason for that. It's kind of a goofy reason, but we took IQ tests every year. And I can remember one year I was so sick when I took the IQ test, and I scored like 17 points lower than I'd ever scored before. I was feeling like crap, and I think I was like the third grade or something. Don't worry, the next year I was healthy, wealthy, and I scored the highest score I ever scored on an IQ test. We didn't have talented and gifted back then, but when I scored so low on the IQ test, I'm not exactly sure how they interpreted it, but they were thinking of taking me out of that program. Funny. Okay, differences in the setting in which the measure is used, differences in the administration of the measurement instrument, poor lighting, noise, tired interviewers, differences in processing, different people interpret the measuring instrument in different ways, and of course that can always be a problem. Different ideas. Systematic or random errors. The systematic errors occur whenever the measuring instrument used consistently introduces a degree of invalidity to all findings. Random errors, by contrast, affect each instance of the measuring instrument's use in a different way. The seriousness of the issues of validity and reliability prompted the development of techniques for reducing measurement errors. Validity. Validity is concerned with the question, am I measuring what I intend to measure? The problem of the validity of the measurement is an outgrowth of the nature of the variables studied. There are three basic types of validity: content validity, empirical validity, and construct validity. Content validity, the measurement instrument covers all the attributes of the concept that you're trying to measure. There are two common types of content validity: face validity and sampling validity. Face validity rests on the investigator's subjective evaluation of the appropriateness of the instrument for measuring the concept under study. So if I were measuring somebody's ability to fly an airplane, and I gave them a written exam about flying airplanes, would that be appropriate? Well, no, it doesn't have anything to do with flying. It has to do with questions about flying an airplane, but it doesn't have anything to do with flying an airplane. They may be the best pilot in the world who do really bad on tests, and so the face validity would be really poor because you can't tell. And you may have somebody else that can memorize all the crap in the world, and so they ace the test, and then they crash the plane. So, hey, wait a minute. Okay. The main problem is I've known people like that. I was teaching, this is when I was teaching at Mississippi University for women. I had a student who memorized everything. She was brilliant. She was in the education program, and she wanted to be a teacher. And she knew everything. She was just fabulous as far as memorizing everything that had to do with, she could memorize a book. So she knew all the answers to all the questions. And that was great. And then when she started teaching, she found out she didn't know how to talk to kids. She couldn't, and she didn't want to discipline them. So her classrooms were chaos. So you know what happened. You know what she did. She became a principal so that she wouldn't have to be in a classroom. And she was good. She was really good because she studied all the requirements, all the important aspects, and then she let somebody else handle the kids. And she did fine after that as a principal, but she was a terrible teacher, just horrible. And she expected everybody to know to be as smart as she was, and that just doesn't work. Even the smart kids didn't have eidetic memories like she had. The main problem is that there are no precise replicable procedures for evaluating this type of content validity. If it is difficult to repeat the evaluation procedure precisely, then the researcher has to rely entirely on subjective judgments, and of course, you don't want to do that. Sampling validity. The researcher develops an exhaustive list of all the domains of the concept under study, then develops a measurement instrument, for example, a questionnaire in which each of these domains is represented. Ascertaining sampling validity serves an important function. It calls for familiarity with all the items describing the content population. Empirical validity is concerned with the relationship between a measuring instrument and the measured outcomes. Scientists assume that if a measuring instrument is valid, the results produced by applying the instrument and the relationships existing among the variables measured in the real world should be quite similar. If a measuring instrument is valid, then there should exist strong relations between the results produced by the instrument and other variables. An example would be an educator seeking proof that the IQ scores of individuals actually reflects intelligence. And the question is, so what is intelligence, and how am I going to determine if it's a good thing or a bad thing? I have relatives who have IQs that are 10, 20, 30 times, 30 points higher than mine. And they live on welfare, and they live in squalor. But they can answer all the questions. Jeopardy, they can memorize things, they can remember things, but they're all on welfare. I mean, so what is intelligence? Is it smart to be a bum? which is what they are, because they won't work. They're not functional. Yeah. Anyway, their mother loves them. I think they're bums. If you don't use your intelligence for something, then is it really intelligence? I could be the best basketball player in the world, but if I won't shoot baskets, then it really doesn't matter that I'm so good. Does it? Predictive validity is the degree of correlation known as the correlation coefficient between the results of a given measurement and an external criterion. An example, an investigator can validate an intelligence test by obtaining the test scores of a group of college students and then obtaining the grade point averages that these students achieved in their first year of college. And that would be the criterion. The researchers then compute a correlation coefficient between the two sets of measurements. The resulting correlation coefficient is called the predictive validity coefficient. Establishing validity of criterion, one method relies on the agreement among researchers that a certain criterion is valid for evaluating a measuring instrument. This agreement is subject to tests of face validity and sampling validity. A different method involves determining the percentage of units of analysis that would be classified correctly by the instrument according to their known characteristics and expressing the relationship between the instrument's measured outcomes and the criterion in terms of a percentage. Construct validity is established by researchers by relating a measuring instrument to the general theoretical framework within which they conduct their studies in order to determine whether the instrument is logically and empirically tied to the concepts and theoretically assumptions they assumes that they are the theoretical assumptions they are employing. To demonstrate the construct validity of a measuring instrument, an investigator has to show that these relationships can be recognized and measured by their instrument. Measuring someone's temperature with a survey or written quiz has no construct validity. How am I measuring their temperature? I got to use a thermometer of some ilk, of some kind. Lee Cronbach and Paul E. Meehl describe the logical process of construct validation in the following order. A scientist suggests the proposition that an instrument measures a certain property, say property A. They insert the proposition into a theory regarding property A. In working through the theory, the investigator predicts which properties should be related to the instrument and which should exhibit no relation to the instrument. He or she collects data that will empirically confirm or reject the predicted relations. An anticipated relationship, if the anticipated relationships are found, the instrument is considered valid. If the predictions are rejected, the explanation for the failure to do so lies in at least one of the three possible causes. The instrument does not measure property A. The theoretical framework that generated the predictions is flawed. The research design failed to test the predictions properly. And one of the problems with research is that people don't like to admit that they got something wrong. Failed experiments are just as important as experiments that work. And we need to talk about the failed experiments so other people don't repeat the same failure. Convergent discriminant conception of validity or multi-trait, multi-method matrix technique. This method derives from the idea that different methods of measuring the same property should yield similar results. Operationally, this means that the correlation coefficients calculated from scores from a given property measured by different instruments should be higher than the correlation coefficients calculated from scores for different properties measured by similar instruments. A measuring instrument should be examined for all three types of validity First, evaluate the theories that should serve as a foundation for the instrument, and this would be construct validity. Next, define a content population of items from which a representative sample is to be drawn, and that would be content validity. Finally, assess the predictive power, the empirical validity of the instrument by relating it to an external criterion. And we used to do this in the laboratory. In the lab, it's really important that you get everything absolutely correct, because let's say you're dealing with somebody's blood, and you need to find out the percentage of red cells in this person's blood, because if there's not enough red cells, then they need to get a unit. They need transfusion, a blood transfusion. So it's really important that we get all this stuff correct. So what do? First, we evaluate the foundation of the instrument. So the first thing that we do is we make sure that the instrument is measuring what we say it needs to measure. It needs to measure the percentage of red cells in the person's blood. Then next, we define the content population of items from which the representative sample is to be drawn. And this would be that blood that we're talking about. We're talking about a tube full of blood or a sampling of that blood. And it has to be well mixed. And we have to determine when we sample it, it has to be well mixed. So it's just like it is in somebody's body. Finally, assess the predictive power, empirical validity of the instrument by relating to an external criterion. So how do we know that our instrument is measuring this thing correctly? What we do is we use a control, and that control is always the same. Or we use a standard. We take a standard and we measure it, and we know that it's supposed to be 42%. It's always 42%. That's our standard. So then we measure it. And if it comes out as 42 or 42.1, we're going, that's really close, and that's right on that's where we need it to be. This instrument is measuring things correctly. But wait a minute. So we standardized it, but now what we need to do is make sure that it's accurate for high results, and we also need to make sure it's accurate for low results. So we use a high and low control. So we do the high control, and it's the high control is 56, and we get a 55.9. So the high control works. And when we run the low control, low control is 21, and we get a 20.9. We know that it's accurate because the two controls are within the limits, and so is the standard. So now when we run the patient's blood, and it's this kid that we think might be anemic, and we get a 28, we know that 28 is accurate because we standardized it. We tested it on a high sample, and we tested it on a low sample. And that's what they're talking about here when they talk about the three types of validity: the construct validity, the content validity, and the empirical validity. We're measuring, of course, I'm talking about medicine, but you can see how the two things potentially go together. If we have an instrument, we need to know that it's measuring things properly. So we need to use an external criterion, an empirical that establishes empirical validity. So when I did my resilience research, the resilience scale had never been used on an indigenous population before, and now it has because I did the work. But we looked at all of these other groups of individuals, that old people, young people, Germans, people from Africa, actually who lived in Africa. We looked at people from Illinois. We looked at people from Kansas. We looked at people from, we had all of this research, and all of it was fairly accurate. So the question is it going to work on an indigenous population? And what we determined was there's no reason why it shouldn't, because it works on everybody else. Why wouldn't it work on an indigenous population? Anyway, Reliability refers to the extent to which a measuring instrument contains variable errors, that is, errors that appear inconsistently between observations, either during any one measurement procedure or each time a given variable is measured by the same instrument. If you measure a board with a tape measure and get 12 feet 6.5 inches one time and 12 feet 6 1/4 inches the next time, the tape measure has a variable error. Social science measures tend to be less exacting than physical measures, so variable errors are not only somewhat common, but expected. So when we measure depression, what does it mean? When we measure resilience, what does it mean? When we measure loneliness, what does it mean? And was it standardized on people at UCLA? UCLA's in Los Angeles. Does that equate to people on the Navajo Nation? I don't know. Let's test it and find out. Since variable errors are so common in social science measurements, the researcher must anticipate seeing an observed score and a true score by any time an experiment is done. In order to correct an observed score to a true score, the researcher must adjust the observed score using a statistical formula to calculate variance. Now remember, we're talking about humans, and humans are different. And we're trying to say that we're going to use a measurement to measure all these people. But not everybody's the same, and not everybody's going to give you an absolute answer to your problem. So what we're going to have to do is we're going to have to use statistics to average these things out, and we will come up with a variance using statistics. Estimating the reliability of an IQ test, we need to think about the discrepancy between observed scores and the true scores for all persons who took the IQ test. To do this, we calculate a measure called the variance. This involves taking the IQ score for each person and subtracting this from each of these scores and the average IQ score across all persons who took the test. So when we're talking about the average, if we have 10 people and the average score was 120 on these 10 people, that would be your average. So if you scored 140, then there would be a 20-point difference between you and that individual. And we would have to use that as a statistic. We'd have to use that in our statistics. To do this, we calculate a measure called the variance. This involves taking the IQ score from Since some of these quantities, xi2 x dash, will be negative and others will be positive, we then square these differences so they're each positive. In other words, we multiply, even the negatives, we multiply it times itself. And the negative times a negative yields a positive. So they're all going to be positive. We then add up these results and divide through by the total number of scores, or the n. Thus, the formula for the variance can be written as this. And I hope that makes sense to you. Okay. Well, let me see. We must consider the variance can be calculated for each of the three n components. For the distribution of observed scores, true scores, and errors, these three variances are then used to generate a reliability measure of IQ. And that's the reliability formula. Now that may be as obvious as mud, and so is this one. But the reality is, so what are we doing? We're taking the average score and we're subtracting our score from it. So if the average is 120 and the IQ score is 135, we subtract the 135 from 120 and we get minus 15. And then we square it, so it's 15 times 15. Negative 15 times negative 15, and we get a positive score. We add all these up and we divide them by the number of scores. And if we had 10, now we're getting the variance. So the higher the variance, the more variable it is, the greater the difference between the average and the score, the higher the variance is going to be. In other words, if we've got somebody with an IQ of 71 and the average is 120, oh, wait a minute, hey, that's like 51. That's not what I said. Okay. In practice, all the researchers have to go on are observed measurements. The true component and the error component are unobserved. As a result, these components must be estimated. Generally, there are three methods to do so: the test-retest method, the parallel forms technique, and the split-half method. Test-retest method derives directly from the conceptual definition of reliability. The researcher administers the same measuring instrument to the same group of persons, or at two different times, and then proceeds to examine whether the two sets of scores covary with one another. Error is defined as anything that causes a person to obtain a different score on the two tests. So theoretically, when I give you a test for Chapter 7, this is Chapter 7, if I give you a test for Chapter 7, and then next week I give you another test for Chapter 7, you should get exactly the same score. You should make the same mistakes that you made before, as weird as that may be. But what will probably happen is, in between now and then, if I test you today and I test you next week, theoretically what's going to happen is that you'll get the same score. But in reality, you'll look up the answer and find out, oh, this was wrong. Now I understand what the right answer is. You should get you should get them all right. Test, retest. I hope that makes sense. And of course, the error would be anything that causes you to get a different score. Test, retest limitations. A measurement taken on one occasion may influence or condition the measurements taken on subsequent occasions. Since many phenomena change constantly, it is possible that changes may have occurred within the period between the two tests. So it might not be you, it just may be the fact that the concept has changed, the content has changed, thus lowering the obtained estimate of reliability. The test-retest method then may either overestimate or underestimate the true reliability of the instrument, and in many cases it is simply difficult to determine what has occurred. Parallel forms technique. A researcher develops two parallel versions of a measuring instrument. Both versions are given to the same group of persons. The researcher examines the covariation between the two sets of scores. With this technique, however, the problem arises as to whether or not the two versions of an instrument are in fact parallel. You probably have had professors that gave you they had two tests, A and B tests, and you either took A or you took B. The idea was that the two were parallel. You should get the same score. But if you gave somebody A on Monday and then B on Tuesday, then potentially what will happen is the two scores won't be the same. One test may be easier than the other, or one test is harder than the other. The split-half method estimates reliability by treating each of two or more parts of a measuring instrument separately. The example, dividing a questionnaire into two parts, such as odd-numbered and even-numbered questions. Each of the two sets of questions are treated as a separate questionnaire and scored accordingly. The researcher then examines the degree of covariation between these two results. Oh, wait a minute. Let's take a quick look. Let's do this. Okay. Let's answer all the odd questions. Following heavy metal has been mined and has caused problems on the Navajo Nation. It's uranium. The Navajo Nation is located in which of the three states? The other indigenous tribe, the Navajo, have recently had grazing and ownership conflicts with. The Hopi, the seat of government. Now that one's kind of tough because if you don't know the Navajo Nation, then you're not going to know Winter Rock's the capital. pardon, it's not really the capital, it's the seat of government. And then 9 would be the Navajo people call themselves the Dene, which means children of the holy people. How difficult are the even numbers? How many people speak the Navajo language? You guys might not even know that answer. The Navajo share a language with the Apache. That's fairly simple for somebody that lives in the Southwest, but not maybe somebody from New York. COVID-19 has caused many deaths. You'd have to pay attention to the news in order to get that one right. Environmentally, the Navajo Nation is mostly high and low desert. The Navajo Nation recently closed the largest coal burning plant. It looks to me like the even numbers are a little bit tougher than the odd numbers. So what we would have to do if we were going to do the split in half method would be we would have to grade each of these to determine which ones were hard and which ones were easy, and we'd have to put the hard ones and the easy ones in at the same time. Here, let me switch this. Calibri. Oh, there we go. New Times Roman. I like that much better. Save. Yeah, let's save it. Okay. Split half method. So that's what we would have to do. Generalizability is the extent to which the research findings can be generalized to larger populations than were tested and applied to different settings than the setting of the initial research. The lights are not working. Did you check them all? No, but I checked a random sample that should have been representative of the entire population. Oh, that's good. Okay, let's go ahead and get into Chapter 8. Population is the complete set of relevant units of analysis or data, and the sample is a subset of the population. So if the population was everybody on the Navajo Nation, and the sampling would be just the people that took our survey, that would be it. You know, there's what, 175,000, there's more than that. What, 225,000 people on the Navajo Nation, and if we tested 2,000 of them, the 2,000 would be our sample, and the population would be the entire 225,000 people. Parameter and attribute found in the population that can be measured. Okay, what are we measuring? Loneliness. We're going to measure loneliness, and we're going to measure, well, knowledge. It would be silly for a Navajo to take the Navajo knowledge test. That would skew our results. We want to know what the answer is in the general population. Around the world, sampling theory. The objective is to provide the basis for making accurate estimates of the unknown values of the parameters based on calculated sample statistics. To estimate unknown parameters accurately from known statistics, researchers have to resolve 3 major problems. The definition of the population, and we were talking about the Navajo Nation. The sample design, how are we going to sample them? Do it just this chunk of people, size of the sample, and in this case it was 5. The unit can consist of individuals, communities, people with shared characteristics, cities, countries, however you want to do it. Determining population poses challenges. The population has to be defined in terms of content, all voter-eligible Hispanics, extent in the United States, so we're talking about all voter-eligible Hispanics and only the ones in the United States, of course. And the time, November 6, 2012, the date of the 2012 presidential election. There you go. Sampling unit, a single member of a sampling population, a voter, a household, an event. Sampling units usually have numerous attributes, one or more of which are relevant to the research problem. The sampling unit is not necessarily an individual. It can be an event, a university, a city, a nation, or even a document. Finite population contains a countable number of sampling units. For example, all the registered voters in a particular city in a given year. Infinite population consists of an endless number of sampling units, such as an unlimited number of coin tosses. Give it to me straight, Doc. How long do I have to live? I'm afraid you've only got a few minutes left if you don't give me the map to the treasure. Wow, that's funny. A sampling frame should include all the sampling units in the given population, but such information is rarely available. Instead, researchers usually have to use substitute lists that contain the same information, but that may not be comprehensive. Okay. A sampling frame for smaller studies may be based on telephone directories, city directories, or membership lists of private and public organizations. The researcher has to ensure that there is a high degree of correspondence between a sampling frame and the sampling population. Defining your sampling frame, let's survey a representative group of males ages 13 to 17 with incomes over $13 million that refuse to change their hairstyle. And of course, that would be Justin Bieber, according to this. The sampling frame must be evaluated for potential problems. Incomplete frames, clusters of elements, blank foreign elements. Incomplete sampling frames are when sampling units found in the population are missing from the list, such as if you made your list of people with home phones, you'd miss all the people with cell phones. If you were looking for the voting population, but you were only looking at people with permanent who lived in houses instead of people that lived in apartments. If you didn't have any people that lived in apartments, you have a incomplete sampling frame because you're missing all the people that live in apartments. The solution might be use of supplemental lists. The example of the population includes all the new residents of a community from a real estate listing. It might leave out renters. A city directory might be used to supplement the real estate listing. Clusters of elements occurs when the sampling units are listed in groups rather than individually. For example, the sampling frame may consist of city blocks, whereas the study focuses on individuals. One possible solution for the investigator to take a sample of blocks and then list all the individual households in each of the selected blocks. The researcher then selects individuals from each household according to specific criteria. Blank foreign elements occur when some of the sampling units in the sampling frame are not part of the research population, such as the case where the research population is defined as eligible voters, but the sampling frame includes individuals who are too young to vote. Solution: these cases should be treated as blanks and simply omitted from the sample. Yeah, take that kid out, and this kid out, and that kid out, and this kid out, and that kid out. The rest of them can vote. All these, this kid, there's another one, I missed one. Representative sample, the essential requirement of any sample is that it be as representative as possible of the population from which it is drawn. And this I've argued about this on the Navajo Nation. People that I was dealing with, they wanted to deal with, all Navajos are the same. Did you know that? Yeah, they wanted to get their sample from Window Rock, or they wanted to get their sample from Chinle, or from Tuba City, or from Kayenta, or up in Utah. As weird as that is. A sample is considered to be representative. Yeah, and so is that representative? I mean, if you're just taking people from Crown Point, those are the people over in New Mexico. Are they representative of the entire population? Are they the same as the people over in Tuba City? And the answer is probably not. Different ways of looking at things. A sample is considered to be representative, this is an argument that I'm not the only one making this argument. I've talked to other individuals who said, the traditions in other parts of the reservation aren't the same as what we learn at Dene College. And that's possible because things change over time. Stories change. If you tell five people the same story, you're not going to hear the same story back in all five samples. But if somebody writes a book like Wilson did, does that become absolute? Do people in Tuba City go, yeah, that's the way we feel? That's the same way. That's the same story we've always told. Or the people up in Kienta, do they agree with everything Wilson says, or the people in Crown Point? A sample is considered to be representative if the analysis made using the sampling units produced results similar to those that would be obtained had the entire population been analyzed. And of course, that's almost impossible to determine. Probability versus non-probability sampling. Probability sample is distinguished by the ability to specify the probability at which each sampling unit of population will be included in the sample. It makes it possible for researchers to estimate the degree to which the findings based on one sample are likely to differ from those obtained by studying the entire population. Non-probability sample, when there is no way of specifying the probability of each unit's inclusion in the sample, and there is no assurance that every unit has some chance of being included. I just killed a fly, by the way. Being included. Used when a sampling population cannot be defined precisely or when a list of sampling population is unavailable. Non-probability sampling. The four major designs using non-probability samples, convenience samples, snowball samples, purposive samples, and quota samples. And I think we're going to talk about all of those. Yep, we're going to. Okay. Convenience sample is a convenience sample selects whatever sampling units are conveniently available. And that's usually what happens on a college campus. It's easier for a college professor to use his students that's a convenience sample. Is that a random sample? No, it's the people who took his class. Or maybe he went to a couple different classes. But if you went to a biology class or you went to a psychology class, what happened to all those business people? They get left out, poor people. I'm sure that really breaks their heart. A convenience sample cannot estimate the population's parameters from the values of the characteristics obtained from the sample because it's a convenience sample and it doesn't represent the entire population. Snowball samples often are used in combination with convenience samples as a way to sample what is called hard to reach or hidden populations, undocumented migrants, female sex workers, etc. The basic logic of snowball sampling is to identify new sampling units, such as people, by soliciting information from existing sampling units. Researchers are able to increase the number of sampling units available to them in their study. Purposive or judgment samples. Purposive samples require subjective judgment to select sampling units that appear to be representative of the population. Because it is usually difficult to determine why a researcher judges the sampling unit selected as being representative of the sample, it is difficult to determine the probability of the inclusion of any specific sampling unit in the sample. Purposive samples can still be successful. For example, voter polling is usually fairly accurate. Quota samples select a sample that is as similar as possible to the sampling population. For example, if it is known that the population being researched has equal numbers of males and females, equal numbers of males and females are selected for the sample. Groups characterized by specific variables such as gender, age, place of residence, and ethnicity are interviewed. So the quota can be anything. It can be a racial quota, it can be a gender quota, it can be an education quota. Oh, I can't talk to you. You have too much education. I just talked to somebody who has your level of education, more education than you have, by golly. And I don't want to skew my sample by using too many people with too much education. Four common probability sample signs: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Simple random sampling is the basic probability sampling design. Simple random sampling is incorporated into all of the more elaborate probability sampling designs. Simple random sampling assigns to each of the sampling units of the population, denoted by the letter N, an equal and known non-zero probability in being selected. Systematic sampling consists of selecting every kth sampling unit, every 10th one, or every 5th one, or every 7th one of the population after the first sampling unit is selected at random from the total sampling units. The first selection is determined by some random process, such as the use of a table of random digits. Systematic sampling is more convenient than sample random sampling. Systematic sampling is easier to use with very large populations or when large samples are about to be selected. And this is the way we used to do drug testing in the military. We did it by social security number, by the last four numbers of your social security number. Usually it was the last two numbers of your social security number. And you would be surprised. Sometimes we get like 5 people, and sometimes we get 50. Oh, man. So we hated certain numbers. One time we selected the last two numbers of the social security number. We got nobody on base. Happy days. But we had to explain it. Stratified sampling ensures the different groups of a population are represented adequately to the sample. In the sample, use the wrong preposition. All other things being equal, stratified sampling considerably reduces the cost of research. Stratified sampling uses available information on the population to create a set of homogeneous groups based on the variables of interest. Cluster sampling is frequently used in large-scale studies because it is the least expensive sampling design. And we're talking about money, and we're talking about people who don't have it, and that is our research psychologists. Cluster sampling involves first selecting larger groupings, called the clusters, through random or stratified sampling, then selecting the sampling units from the clusters. The choice of clusters depends on their research objectives and the resources available for the study. Fallacies concerning the necessary size of the sample: is that the sample size must be a certain proportion, often set at 5% of the population. So if you're talking about the people in the Navajo Nation, if there's 225,000, let me put this in my computer. 225,000 times 0.05 equals 11,250. That's a lot of people. I don't want to sample that many people. Another one is that an adequate sample size is about 2,000 units. It's about 1/6 of what we would need on the Navajo Nation. Still, another misconception is that any increase in the sample size will increase the precision of the sample results. To determine proper sample size, researchers need to determine what level of accuracy is expected of estimates, that is, the size of the standard error. Standard error is a statistical measure indicating how closely sample results reflect or deviate from a parameter's values. It is calculated from the distribution of all the sample means about the mean of the total of those samples. Standard error measures the level of randomness in the sampling process. The standard error of the sample mean is an estimate of how far the sample mean is likely to be from the population mean. What are we talking about here? We're talking about a statistical evaluation of how far apart your results are from your expected results. That's all we're talking about, standard error. The mean and standard deviation are descriptive statistics. The standard deviation of the sample data is a description of the variation in measurements. The standard deviation of a sample is the degree to which individuals within the sample differ from the sample mean. The standard error, look, if you took a test, if you took a test and everybody got exactly the same score, the standard error would be 0. The standard deviation would be 0. The greater the deviation, the greater the difference between the scores that people had. So on my quizzes, there are 15 questions. If the average score was 11, but I had somebody with a 2 and I had somebody with a 15, now we got this huge difference between standard deviation would be very great because we have so much variability in the scores. The mean was 11, and we had 2 people with a 14 and 9 people with a 15 and 7 people with a 2. We got a mess. We got a mess here. And the standard deviation is just going to be out of sight. The standard error of the mean of the sample will tend to 0 with increasing sample size because the estimate of population mean will improve while the standard deviation of the sample will tend to approximate the population standard deviation as the sample size increases. Why is it moving towards 0? It's moving towards 0 because if 7 people take the test and they get 7 different answers or 7 different scores, now you've got this huge standard deviation. But if 2,000 people take the test and there's only 15 different numbers that you can get, everything's going to move closer to the mean. Everything, because statistically that's the way it works. In order to calculate standard error, you need to calculate the standard deviation. We are trying to discover the standard error and standard deviation in the height of the starting 5 of a basketball team in centimeters. Gina's 170.5 centimeters, Sue is 161, Toy is 160, Freda is 170, and Ty is 150.5. The first thing we do is calculate the mean by adding the heights and dividing by the number of players. So if we add all the heights together, we get 812. We divide that by 5. So your mean is 162.4. We then need to find the deviation, and we do this by subtracting the mean from all the heights. So Gina is 170.5, and the mean is 162.4. So that's a difference of 8.1. Sue is 161. 162.4 is the mean, and that's a negative 1.4. And then Toys, okay, on down and on and on and on. Okay, now we're going to square all these numbers and make them all positive numbers. The next step is to square all the deviations and add them together. Gina 65.61, Sue 1.96, Toy 5.76, Freda 57.72, Ty 141.61. Add all those together and we get 272.7. We will now find the standard deviation of the starting 5 by taking the sum of the deviations squared, 272.7, and dividing by n minus 1, where n is the number of units we have. That's 5 minus 1 equals 4. So we divide 4 into 272.7, and we get 68.175. To calculate the standard deviation, we will take the square root of 68.175, and that will be the standard deviation. 8.257. So the standard error is the standard deviation, 8.257, divided by the square root of the sample size. So the sample size is 5, and the square root of 5 is 2.236. The standard error will be the standard deviation, 8.257, divided by the square root of the sample size, 2.236. In other words, 3.693. Standard deviation of 8.257, standard errors 3.693. If each player were the same height, the standard deviation would be 0. The larger the sample, closer to 0 the standard error becomes, because it makes the outliers less mathematically important. And we had some shorties on the team. I think we had some tall people too, didn't we? Yeah, Ty was only 150.5 centimeters. Okay. And that's how you get standard error and standard deviation. Okay, does it sound complicated? Yeah, well, it's a statistical analysis. So yeah, it's going to be complicated, and we have to do, a lot of different things in order to get the correct answer. But hey, that's mathematics. That's statistics for you. Confidence interval is how much uncertainty there is with any particular statistic. Confidence intervals are often used with a margin of error. It tells you how confident you can be that the results from a poll or survey reflect what you would expect to find if it were possible to survey the entire population. Confidence intervals are intrinsically connected to confidence levels. And this was really important during the last election, because we were talking about polls. And they would say, well, Joe Biden's ahead by 4 points plus or minus 6. Wait a minute, so that means he could either be 10 ahead or 2 behind. Or 4 behind, sorry. Doesn't sound like much of a poll, does it? Since there's so much variability. But that's what we had when we're talking about politics. So even if, and that's one of the things you have to listen to. No poll is absolute. The only poll that could possibly be absolute is on election day, the results. That will be an absolute number. But the polls that we get, they'll take a sample of 1,000 people, and they will ask them if they're Republicans and Democrats, and whether they're planning on voting for Joe Biden or Donald Trump. I'm not saying the next election is going to be the same thing. I'm talking about the 2020 election. So when they finish the poll, they'll say, well, in our poll, Joe Biden was ahead by 4 points, plus or minus 2, which means, well, he could be ahead by 6, or he might be only ahead by 2 if it's plus 2, which is pretty low if you think about it. So when the Republicans do surveys, they like to survey Republicans and independents. They leave the Democrats out. So in their poll, of course, it's going to look better for their candidate. And when the Democrats do their poll, guess what they do? Exactly the same thing. Because you can't survey the whole population. Sorry, my wife just got home, and the dogs are all excited. A confidence interval for the mean is a way of estimating the true population mean. Instead of a single number for the mean, a confidence interval gives you a lower estimate and an upper estimate. For example, instead of 6 as the mean, you might get 5 and 7, where 5 is the lower estimate and 2 is the upper. Or 6 plus or minus 1, I guess. Yeah, 6 plus or minus 1. A normal curve is a theoretical distribution of a great significance in the field of statistics. Some of its major properties are: it is symmetrical and bell-shaped. The mode, the median, and the mean coincide with the center of the distribution. The curve is based on an infinite number of observations. A single mathematical formula describes how frequencies are related to the values of the variable at any normal distribution. A fixed proportion of the observations lie between the mean and fixed units of standard deviations. A normal curve, if a given sampling distribution is known to be approximately normal, we can infer that about 68% of the sample estimates it comprises will lie between its mean and one standard deviation, and about 95% between its mean and two standard deviations. And that's what a normal curve looks like. So if you, and this is what they call a bell-shaped curve. So if you ever see something like this, it's normal. It's a normal curve. Estimating the size of the sample to be drawn, recall the formula for the standard error of the mean. Standard error equals S over the square root of n, or S is the standard deviation of the variable under the study, and n is the sample size. Inverting this formula, we then have n equals S squared over SE squared. If the sample size turns out to be too large relative to the population, the finite population correction is added. In this case, n is added to 1. The final sample size is thereby calculated by n equals n over 1 plus n or n. Why are we talking about statistics? Anyway, decisions concerning the sample size. First, researchers must decide how precise they want their sample results to be, how large a standard error is acceptable. Second, they must decide how the results will be analyzed. Third, if more than one variable is being examined, the researchers should decide whether a sample size satisfactory for one variable is adequate for the other variables. Sampling theory is concerned with the error introduced by using a sampling procedure. In survey research, the most common error is non-response error. Non-responses are defined as observations missing for reasons such as the refusal to be interviewed, an individual's absence from the home, and misplaced forms. Non-response can introduce substantial bias into the findings. The amount and kind of bias is related to the following condition. The greater the rate of non-response, the greater the bias introduced. The response rate can be calculated as follows. Now, this is really kind of interesting because the census is actually a sample, is actually a sample of the population. And the reason is because they try to count everybody, but we get non-response rates. My wife was a census taker in the last census in 2020, and she got a lot of non-responses. Now, non-responses are acceptable because it's all statistics. So then we take the absolute number that we get, the people that we are able to count, and we add in the non-response rate. And then we have to estimate the population from those numbers. Isn't that interesting? So even the census, where we try to count everybody, it's impossible to do so. There may be more people in the house than we thought there were. There may be fewer people in the house than we thought there were. The greater the rate of non-response, the greater the bias introduced. The response rate may be calculated as follows: R equals 1 minus n minus R over n, where R equals the response rate and n is the sample size. The seriousness of the bias depends on the extent to which the population mean of the non-response stratum in the sample differs from that of the response stratum. Each of the following types of non-response influences the sample results in a different way. Uninterviewables, people who are ill, illiterate, or have language barriers. Not found, people who have moved or are inaccessible. Not at homes, people who are out when the interviewer calls but are reached later and their responses are subsequently added. And refusals, people who refuse to cooperate or to answer all the survey questions. And this, of course, was fairly common with my wife's sampling of the census in Iowa. And that is the end of the chapter. So I'll talk to you guys again next week. We'll try to, if you have any, I will put that, my questionnaire, my knowledge of the Navajo Nation, general knowledge about the Navajo Nation on the website. And if you see something that you'd like me to change, then I can change it. If you see something that's inappropriate that I've said, if I used words that are not used anymore, then you need to tell me and I will change it. Okay? So I'll talk to you guys next week.